maybe to just do a quick introduction of Joe. Joe is the CEO of Volexion, an advanced materials company using graphene-based cathode coatings to improve lithium-ion battery performance without changing how they are made. With more than 20 years of experience in the industry, he's held leadership roles at Sylvatex. I probably botched that. Thank you. Ionic Materials, 24M, and A123, helping to move technologies from lab to commercial reality. At Volexion, Joe is guiding the company's scale-up and market rollout while building partnerships across mobility, defense, and energy storage. He holds degrees in mechanical engineering from Cornell and an MBA from MIT. With that, I will hand it to Joe, and thank you.
I have been in batteries for a while. This is true. Thank you for having me. I'm Joe, I'm CEO at Volexion, and I'm here to talk to you today about how we can use the power of graphene to enhance battery performance. For my investor friends in the audience, I typically start this out by talking about what a great time it is to be in batteries. Right? Despite all media protestations to the contrary, I think everybody here anyway would agree that the electrification of everything is an inevitability at this point. And you know, as investors, no one ever said buy high, sell low, right? The reality is today, battery valuations, not the highest they've ever been. So it's a great time to be in batteries, especially for a company like ours, much more performance materials business with a really nice and juicy margin profile. We're a bottom line driven business, and I look forward to telling you all about that. We structured the business over time to try and avoid some of the previous pitfalls of battery investments. And that's to say, generally, we structured the business. I always try to work right to left here rather than left to right. We're a capital light, asset light business with a shorter time to commercialization that's focused primarily on improvements on the cathode side of the battery, where less than 5% of invested capital to date has really been put to work, right? You hear a lot about lithium metal, you hear a lot about silicon, you hear a lot about solid state, but you don't hear a lot about technologies that improve cathode active material performance and therefore the performance of batteries overall. Finally, we're a platform technology. We are chemistry agnostic. We work across LFP, NMC, NCA, LNMO, LMR. I've got some sodium friends that we're doing some business with, but it really is a platform play in that sense. So we do two things at Volexion. The first thing that we do is we make a low-cost, high-performance graphene material. And this is really important because historically you've only been able to get one of two things. And that's a low-cost, low-performance material or a high-cost, high-performance material, neither of which, as battery folks, is useful in a battery for one of the other reasons, right? And the reality is batteries are nothing more than a whole bunch of materials touching each other that frankly don't like to be touching each other, right? And graphene is a fantastic interfacial modifier. Chemically, electrically, mechanically, it brings all of these types of benefits to bear on cathode active materials. So that's thing one. We make a low-cost, high-performance graphene material. Thing two, we coat things with it. So in this case, we're coating cathode active material. And what does that do? It really serves to create a barrier that keeps things out that we don't want in and keep things in that we don't want out, right? So you're preventing unwanted chemical reactions between the electrolyte and the cathode active material surface to improve performance overall. What does improved performance overall mean? If you want to talk about a single nice number, we talk about 25% energy density improvement and cost reductions. The reality is customers all use different materials. Every cathode active material is different, every electrode design is different, every cell format's different, every set of application requirements is different, it's all different, right? So that's both sides of the same coin of my job. I get to talk about a broad set of product improvements while working with customers to try to identify what pain point we can actually solve for them. Cycle life charts. Wouldn't be a good battery presentation without cycle life charts. On the left, what you see is a coated single crystal NMC 811, right? Coated versus uncoated. On the right-hand side, existed new class of materials, right? Lithium manganese rich or LMR materials. Again, coated versus uncoated. These are all 45 degrees C. We're trying to do accelerated testing here, right? But you can see the general improvement that we get coating the cathode active material versus uncoated. We are a performance materials business. At the end of the day, we're looking to sell material by the kilo, by the ton, by the supersack, by the tote, however you want to do it, we're going to be selling graphene. The CAM manufacturer, at the end of the day, will replace their existing coating techniques with the coating of graphene. This is all technology that's been developed out of Professor Mark Hirsham's lab at Northwestern University. And all of this excitement has led to a great pipeline of customers. We've got 2 JDAs in hand. We're delivering multiple kilograms of material to some of the leading OEMs, both over here in the US and over in Europe. Today, we deliver about 10 kilos of material at a clip. I'm raising Series A. We're going to put a pilot line in place, again, relatively capital efficient, use $2.5 million of that Series A to deliver up to 100 kilos a day or 25 tons of material a year, which is really the next phase that we're going to need to demonstrate the viability of the product to customers at scale. It's a great team. Again, co-founders, Professor Mark Hirsham out of Northwestern, as well as Damien Despinois, who's now our COO and president, Jonathan Vistorino, our CTO, deep history in advanced battery materials. We raised a seed round and a bridge, both led by Clean Energy Ventures, a Boston-based firm, as well as Earth Foundry, who's based in Chicago. Had a bunch of non-dilutive funding as well from different government agencies, which has been fantastic. I think I usually close this with 2 primary points. The first, again, performance materials company, nice healthy margins, unheard of in the battery industry, 60, 70-point margins. We're a bottom line driven company. I'm not going to be the next billion-dollar revenue company, but I will certainly throw off as much cash as that company will. So if you care about cash, you should care about us. And the second and the last point is CAM is just the beginning. If you go back to what I said earlier, we do 2 things. We make a low-cost, high-performance graphene material, and we coat things with it. There are plenty of interfaces out there in the world for us to coat, so CAM is just the start. Thanks a lot for having me.
Talking about graphene, and you have a lot of different applications, but if you try to make that graphene and into different applications, do you need to kind of like adjust like for the different application to make a different graphene, or it's all the same?
No, it should all be the same. We make, and to be clear, we make a pristine graphene, so it's not graphene oxide, it's not reduced graphene oxide, it's not functionalized graphene, so it's going to be 5 layers of carbon pristine graphene. So we have control over the morphology of the graphene, so I can change the platelet size if that makes a difference in a specific application. But from a process perspective, we don't really change anything.
Okay, then you mean that material could be used in all different circuits?
Yes, I'm working on a thermal interface material right now for chipsets and data centers and things like that, and we use the exact same material that we use to coat CAM.
Do you see any like adding more, like you said 5 layers, but like making it more thinner or thicker, and it should make like a difference?
We get the performance that we need out of it the way it is. I think making it thinner would probably be more costly, and there's a fine balance between cost and performance for the material.
Hi, that was great.
Hey.
Thank you.
How are you?
Succinct, to the point, I loved it. So I'm not a materials engineer at all. A lot of this goes over my head technically, but I'm curious, 25% cost reduction and energy density improvement sounds amazing. That's huge. What's the trade-off? What's the catch? It just sounds too true.
There's no trade-off. There's no catch. I'm happy to leave my card and we can talk. I'm raising. It's great. You have money. I need it. Great.
Perfect. What about the technical mode then? How do you plan to?
So there's IP, right? So we've got IP on the process of making the graphene itself, right? And I think even more importantly, we've got composition of matter IP on the composite of the graphene with cathode and also anode active materials. So there's obviously a lot of trade secret knowledge in the production and the coating as well, but we have got IP in both cases.
Thank you.
Yeah.
Any audience questions?
Julia, sorry, two quick technical questions.
Yeah.
Question number 1, so are you trying to prevent CI formation altogether?
That's a good question.
You can't answer.
Yeah.
Gotcha.
I would say no, but it is an
Understood.
artificial interface. Yeah.
Understood. Because cathodes behave differently with cycling,
Yep.
a little bit of shrinking, a little bit of expansion.
Yep.
How is your coating holds up in terms of no coating versus coating in terms of cycle life?
Yeah, so you're talking about degradation of coating over time. So if we look at it post-cycling in those cycling charts, you still see the coating intact.
What does it take to integrate yours into a manufacturing plant? Is it, I assume it's a liquid phase or slurry process, is it just a slurry coating process that you add in, or what does it take actually?
So to coat the cathode active material, we use all commercial off-the-shelf equipment. So production of graphene as well as coating. So it would be all equipment that a CAM manufacturer would be very familiar with. We have both solution-based as well as dry processes for the application. Yeah.
You have this universe of possible applications.
We do.
Why did you choose batteries as your first application? What did you?
Great question.
Choose a battery company.
So, it's sort of the genesis of the company. So Professor Mark Hersham at Northwestern was working over with Professor Thackeray over at Argonne on reduction of manganese dissolution in LMO-based cathode materials back in 2017, 2018. So the start was in battery materials, and that's just how the company got spun out, got formed, and that's what we've been working on ever since.
Seems like there might be applications that are shorter.
Easier?
Market.
Shorter? Yeah, there might be. Just a few. I'm a glutton for punishment.